you test your smaller percent, if your smaller percent works, your larger percent has to work. If your smaller percent doesn't work, then you're done. No need to test anymore anyway. So if you test this guy first, since he's the smaller percent, you can see that this doesn't work. So whatever else that problem said to do, we can't do. We stop. We just say, does not approximate a normal curve. And we only work with normal curves here. The only time we didn't work with the normal curve was Chebyshev's theorem, just for like one little short day or two. The next one we test, you can see as your probabilities even out, like they're not one so low and one so high, or your n gets a little bit bigger.
Where are you getting the 5 from again?
That's the formula that you're testing against. Because remember the graphs we looked at yesterday? And how they became closer and closer to a normal curve as n times p was more than 5. And as it got really even higher, it got really even closer to a normal curve. That's just the standard you have to test against.
So it's always 5?
Uh-huh.
Okay.
Both of those. This guy, the easiest way to start this is like this. Can I use 109 if I say x is greater than 109? What's the first number that I'm going to use if I say x is greater than 109? 110 is my first number. Take this guy, drop it down. So I'm 109.5. It's going to keep the same inequality sign. The only difference that the book does, like I said yesterday, they drop the equal sign. I leave the equal sign, just so that I know what my original statement said. Does it have any effect, this equal sign? No. Well, this one didn't have one. But no anyway, because I would never hit a 109.5. I'm still a discrete measurement. I'll never hit a 109.5. I'll still hit the first one, 110. So the equal sign doesn't really matter in here. So the book says just drop your equal sign. I say keep the original, whatever you like to do. This guy now is different. Because this one said, oh, you're going to count 109. You're going to start at 109, then 110. It's still a left end. So you're going to drop down to 108.5. Same inequality. This guy, we go the opposite way. We're going to end at 109. Just make sure you go this way. This is an upper level. So take this guy and increase your upper level by 0.5. You're expanding that bar. This one is similar, but it says do not stop at 109. You can't use 109. So I can stop at 108, then 107. So this guy I have to bring to 108.5. And again, you can keep your equal signs in there if they're originally there, or not. It doesn't matter. I will not mark it wrong either way. Okay, number 9. I think you had to match these up to the words, right? Did you match these up to the words or no? What did number 9 say? Okay, so in words, I said I want less than 25. You could say less than 25 successes. You could say fewer than 25. Less than is probably your norm. And how would I write that? Well, I can't use 25. It has to be less than that. So it's got to stop here at 24. Can't use 25. It's got to be less than that. So this is where I raise mine. So this is your statement corrected for continuity. And when Thursday we resume this, that's what we're going to put in your z-score formula, and everything else works exactly the same. Number 10 says the probability of getting greater than or equal to. Another word we use for greater than or equal to is at least. And if you put greater than or equal to, I'm fine with that. That means I can start at 110. I can use that because of my equal sign. It always needs to be greater than or equal to, so I'm going to drop this down to 109.5. Are you guys comfortable with that? That's the key to this whole unit. That and the NP thing. Because it works a little differently. Number 11. Excuse me, says I'm exactly equal. We didn't do an equal yesterday. So here's my bar. Here's 33. That's the normal curve. Here's my bar right here at 33. If it's the only number I have to expand it on both sides. I have to come out 0.5 here and out 0.5 here. Because I need to make it a bar, because it's a discrete number. I need to make it so that when I do this, remember how we get all the little bars of things in here? I need to get this whole area under this bar. So I just drop it 0.5 and raise it 0.5. Greater than, you could say getting more than, you could say greater than, whichever way you like to say it. I probably like the greater than. Greater than means, can I start at 65? If it's greater than 65, can I use 65? No. I have to be greater than. This is the first one I'm going to use. So I'm going to drop my lower end to 65.5 and make my inequality statement. Probability that x is less than or equal to, you could say less than or equal to. Another word we use for that is at most. That's the most I could get. So can I use 150? If I can get that, yes. So I take this and I boost that up 0.5. Here's an in-between. Now you have to be careful. They said getting between 55 and 60. They didn't say inclusive. So on my number line, this would look like this. I wouldn't be able to use those 55 or 60 because I want the in-between numbers. So if I started like this, I can't use this one, I can't use this one. I need the numbers in between there. So I take this one, drop it down to 55.5, take this one, raise it to 59.5. That's different than yesterday's inclusive. Inclusive said, include those. You can use those. Between says you can't use them. Everybody good with these? I know they seem basic, but as soon as we put this whole thing together, that's where the mistakes are. So make sure you're good with this. When